In this video, we're going to solve some logarithms and exponents by first getting the log or exponential on one side by itself. Once it's on one side by itself, we're going to use the inverse function to get rid of it. So if we're trying to solve a log, we'll use an exponent, and if we're trying to solve an exponent, we'll use a log. So to just give us our little example to start before we jump in, if you get log base 7 of x on one side by itself equals 2. Once you have that log by itself, you want to use that same base of an exponential to get rid of it. 7 will cancel out with log base 7, so you'll just be left with x equals 7 squared. So x is 49. So that's the concept we want to use throughout. We want to get the log on one side by itself, just like this first step says. And then we want to use the opposite operation to get rid of it. So an exponent will get rid of logs. So I'm going to start with these log ones here. So looking at letter A, we have log of x equals 3.15. So the log is already by itself. We want to use base 10 to get rid of that log. So 10 to the log of x will just give us x equals 10 to the 3.15. There's our exact answer. And then I'm going to grab my calculator and use my calculator to get the approximate answer. So I'm going to plug in 10 to the 3.15. And we're supposed to round to the 100th decimal place, which will be the second decimal place. And I'm getting 1,412.54. And you could plug in to check if this is right. You could plug back in to the original function. You could do log of 1412.54, and you'll see that you'll get about 3.15 out. We can move over to this next one. Log base 2 of x plus 5 equals 6. So first I need to get the log on one side by itself. So I'm going to get rid of the plus 5 by subtracting 5 from both sides, which will leave me with log base 2 of x equals 1. And now I want to get x all the way by itself. Now that I have the log on one side by itself, I can use base 2 to cancel out with log base 2. That way we get x by itself is 2 to the first. And so that's my exact answer, and I can plug into my calculator to see if I get a decimal for that. Well, 2 to the first is just 2. So we get x is 2 as our exact answer, and we don't really have a rounded answer because it comes out to be a nice whole number. The next piece says we're going to move down to this 4 plus ln of x equals 6. And I want to get the log on one side by itself, so I'm going to subtract 4 from both sides, which is going to give me ln of x equals 2. And I want to cancel out an ln, so we want to remember what base ln is. Ln is base e. So these e and ln will cancel, so x is going to be e to the 2. There's my exact answer. And then I want to grab my calculator and plug in e squared. I'm going to get to the e by doing second ln on the calculator. And e to the 2, rounded to 2 decimal places, would be 7.39. There's my rounded answer. Okay, I'm going to move down to letter F. I'm trying to solve all the logs first, then we'll come back to the exponentials. So looking at letter F, I have 8 minus log of x equals 11. So first task, we want to get the log by itself. So I'm going to subtract that 8 to move it over. It's going to give me negative log of x equals 11 minus 8 is 3. And we want to think, do we have log on one side by itself? Well, we actually don't. If we had 5 log of x, it'd be obvious that you needed to divide by 5. If it was 10 log of x, you'd know to divide by 10. If it was 8 log of x, you would divide by 8. But for some reason, we forget when it's a negative 1 coefficient out front that we need to divide by it. So we want to get log by itself. So we don't want negative 1 log of x. We want to divide both sides by negative 1. So we get log of x equals negative 3. And to get rid of the log, we're going to raise it from base 10, since that's the base for the common log. So x equals 10 to the negative 3. There's my exact answer. The exact answer is whatever answer you have before you plug it into your calculator. And then we can get the calculator answer by plugging in 10 to the negative 3, which is going to give us 0.001. Now we're going to go back on the other side and do those last couple problems, which are a tiny bit different because we're not solving logs, instead we're solving exponentials. We're going to treat it the same way. We want to try to get the exponential by itself. So I'm going to subtract 3 to get e to the x equals 10 minus 3 is 7. And now I want to get rid of base e. So I want to take log base e of both sides. Log base e is just that ln. So we're going to take ln of e to the x equals ln of 7. So that ln and e will cancel, so x is ln of 7. There's my exact answer. And I'm going to grab my calculator and use that ln button to get the rounded answer as well. So it says find both the exact and rounded answer. And for the decimal answer, I'm getting 1.95 when we round to the second decimal place. Same thing with this last one. We have 10 times 5 to the x. So first of all, I'm going to divide by 10 to try to get that 5 to the x by itself. So I'm going to get 5 to the x equals 100 divided by 10 is just 10. And now I want to get rid of base 5. So I'm going to do log base 5 of 5 to the x equals log base 5 of 10. So I'm going to get x equals log base 5 of 10. There's my exact answer. Now to get the decimal answer depends upon what kind of calculator you have. So check on your calculator. If you hit math and scroll down to the letter A, so through all the past numbers to letter A says log base, and you can change the base of the log in your calculator to enter in this exactly. If you do not have that under the math button, if you don't have anything to change the log base, you would have to enter this in, and that's if you have a TI 83 plus or below, you would need to enter in using change of base. You do ln of the number over ln of your base on bottom. Otherwise, you can do math letter A, and you won't have to use that change of base formula. But we need to be able to plug in on our calculator either using the math and scrolling down to letter A. If you have a TI 84 plus or beyond, you should be good to change the base on your calculator. If you cannot change your base, you need to do ln of the number over ln of your base. And either way, your answer for the rounded number should be 1.43 as your rounded answer. So math letter A if you have a TI 84 plus and beyond. And then if you don't have that ability, you're going to do ln of 10 over ln of your base is 5. And you'll get 1.43 as the rounded solution.